everyone, and welcome to 8.3, Polar Form of Complex Numbers and de Moivre's Theorem. This is the first video in a series of videos. What I've done is I've chopped this lesson up into several shorter videos, trying to focus on one or two concepts in each video. So in this video, we're going to do a quick review of what a complex number is, and how to graph it, and how to find its absolute value. Now these are all topics that you should have done in Algebra 2. So first, you'll notice that I have a complex number written here on my board. The real part of the complex number is the plain number that doesn't have an I attached. The part with the I is the imaginary part. And together, an imaginary part plus a real part is called a complex number. Now, technically, you don't have to have an imaginary part or a real part. Any number can be written as a complex number. So it could just be 3i can be considered a complex number. 2 technically can be considered a complex number, although I'm not sure why you would. But yeah, that's how complex numbers work. Now, they can be graphed on what we call the complex plane. In the complex plane, we have our imaginary axis. Okay, and we have our real axis. Okay, so basically all we do is we take the number, the real part, 2, so that says go to 2 on my real axis, and then plus 3i that says go to 3 on my imaginary axis, and I graph the point. So this point, if I wanted to label it as Z1, okay, would be right here if I was to graph it. There's my Z1. Okay, let me show you that again. Okay, let's say I have Z2, which is 3 minus 2i. So my real part is 3, and my imaginary part is negative 2. So this would graph as the point 3, negative 2. So I go to 3, negative 2, and here is my Z2. Okay, now sometimes what they do is they ask us, they give us these two, and then they say, okay, graph Z1 plus Z2. And what I would have to do is actually add these together and then graph that. Okay, so I would just combine like terms. I have 2 plus 3 is 5, and 3 minus 2 is 1i. So I just combined like terms, and this is what I need to graph, 5, 1. So 5, 1 would be right here, and this is Z1 plus Z2. Okay, so that's the basics of graphing. Okay, so remember the I values go on this vertical axis, what used to be the y-axis, and the real parts go on the real axis, the horizontal axis, or the x-axis. Now, sometimes they're going to ask you to graph a set of numbers where they use inequalities to describe them. So let me show you what that would look like. Okay, a set of numbers generally is going to be given in set builder notation. So they might say graph the set of numbers defined by a plus bi such that a is greater than or equal to 0. Okay. Now notice they haven't given us any limits on our I values. So that means our I values could be any number on this imaginary axis. But they have told us that on our real axis, we have to be greater than or equal to 0. That means I could equal 0. So this would be where my real axis equals 0, this line. And it's a solid line because it could equal. And I'm going to graph anything where a is positive on this side. And I would just shade this with my pencil. So this is how that would graph. I'd have a vertical line that matches up with my y-axis, and I'm graphing everything to the right of it because those are all the places where a is greater than or equal to 0. Let's see another one because that can get kind of tricky. In this one, I'm going to give you limits for both a and b. Okay, so now we have a new set to graph. I have t equals a plus bi such that a is less than 1 and b is greater than or equal to 0. Okay, so a is less than 1. Let's start with that. A is my real part, and it says less than 1. So I'm going to draw a dotted line here at 1 because it can't equal 1. And anything less than 1 would shade on this side of it. Okay. Now b is greater than or equal to 0. That's on my imaginary axis. Now it can equal 0. So that would be this solid line right here. And it says greater than or equal to that. Now greater than that would be above it. So basically my shading is going to overlap up here. So this is the part of my graph that needs to be shaded up here. And that's how I would graph that. Okay, let's take a look at absolute value of a complex number. So for any complex number, I can find the absolute value basically using the Pythagorean theorem. Okay, remember, absolute value is a distance from 0. So remember, when I'm graphing these, let me go to a graph. If I'm at 2 over and 3 up, so this is 2, and this is 3, then the absolute value is going to be this distance here. Okay, now notice this makes a right triangle. Okay, so to find this distance, I'm going to do 2 squared plus 3 squared, and I'm going to do the square root of that. That's exactly how this works. Remember, this is my real axis, this is my imaginary axis. So this complex number would be 2 plus 3i. Notice it's a squared plus b squared and the square root of that. This is the Pythagorean theorem. The distance from the origin is going to be a squared plus b squared and the square root of that. And that's how we would find that absolute value. Okay, so the absolute value of a complex number is written like this. Now usually we use z's for complex numbers, so it's the absolute value of z equals the square root of a squared plus b squared. Okay? So if I was given 3 plus 4i, I would do, for the absolute value of that, I would do 3 squared plus 4 squared and the square root of that, which comes out to 9 plus 16, which is the square root of 25. Also known as 5. Now notice I didn't put the plus or minus sign here because absolute value is a distance and distance can't be negative. So that is my absolute value. Also know that absolute value produces a positive. So that's another reason why. Let's look at one more. I have 8, and I wrote a 5. I have 8 minus 5i. And I want the absolute value of this. So it's going to be the square root of 8 squared plus, now watch your signs here. I have to square negative 5. So whenever you square a negative, it turns positive. So this is 64 plus 25, which is the square root of 89. And 89 isn't a perfect square, so I'm just going to leave it like that. Now let's look at another one where we have to graph. Okay. This time what they're going to do is they're going to make our set so that we have an absolute value involved. Okay, so what they've told us is that set C is the set of all complex numbers such that their absolute value is equal to 1. Okay, so the distance from the origin has to be 1, which means I'm 1 unit out in this direction, 1 unit out here, 1 unit out here, 1 unit out here. It's going to make a circle, which is basically the definition of a circle. The circle says it's the set of all points with a given radius, and in this case that radius is 1. Okay, I have one more set to do. Set D is the set of all complex numbers such that their absolute value is going to be less than or equal to 1. Okay, so the absolute value is less than or equal to 1. So I've already got all of the ones that are equal to 1. Less than 1 would mean that I'm going to fill in this circle. Okay, I'm going to fill it in and shade it in to get all of the ones that are less than it. Okay, so that's it for this video. Let me know if you have any questions and come back for the second part.